Okay, so number 23 and 25, they want you to look at the graph and write down which intervals, open intervals, are decreasing, increasing, or constant. So if you look at number 23, we've got a line with a positive slope. So the line, again, remember, we read a graph from left to right. So as you go from left to right, it is going up forever. So it's forever increasing. So we say that the interval, so right here, decreasing, nothing, constant, nothing, but it's increasing from negative infinity to infinity. Okay, for number 25, let's here. From negative infinity to 0, because remember the interval denotes the x values. So we're writing down at which x values is the function increasing, decreasing, or constant. So again, going from left to right, it's increasing from here to 0, then it decreases, and then it increases. Okay, so you would write for decreasing, you could put from 0 to, let's see, 1, 2 tick marks. And then for increasing, from negative infinity to 0, and then from 2 to infinity. And there are no constant intervals. Okay, for number 27, it's f of x equals 3, so that's the same as saying y equals 3. So it's a horizontal line on y equals 3. So this one would be constant from negative infinity to infinity. Okay, so this one, 29, is f of x equals x to the 2/3. You put it into a graphing calculator, and the graph turns out something like this. Okay, so this one, if you look from left to right, which is how we read a graph, it's from left to right, it's going down, and then at 0, at x equals 0, it starts going up. So we say it's decreasing from negative infinity to 0, and it's increasing from 0 to infinity. Okay, for number 31, again, put it in, it's not a very common function, so put it into a graphing calculator such as Desmos, and you get a picture that looks something like this. Something like that. Okay, and then right here at negative 2 is where we have like the where it changes direction, the lowest point. So, and then at negative 3 there's a dot. So then we say that it's, again, we're going left to right, so it's decreasing here, and then from this point on it increases. So we write decreasing from negative 3 to negative 2, and increasing from negative 2 to infinity. 33 again is not a common function with the sum of two absolute values of x plus 1, x minus 1. And this one ends up looking something like this. Okay, now it's not exact, I mean, that's a pretty close picture right there. Okay, so again, read from left to right. So as I come in from the left, the function is decreasing. Then there's a section interval here where it's constant, and then it starts increasing. So we write that down. Decreasing from negative infinity to negative 1. Constant from negative 1 to 1. Remember, the intervals we're writing down the x values where this happens, and then the increasing from 1 to infinity. Oops, infinity. Okay. Number 35 is a parabola, which opens up. It has x-intercepts at 0 and 6. Okay, and knowing that, we know that the vertex is halfway on the line x equals, 3, which is halfway between 0 and 6. So on the line x equals 3, we find the vertex. So replace the x with a 3, and that gives you negative 9. So something like this. Okay. Now, if you forgot how to graph it, you could have just put it into a graphing calculator, but with a function like this, like number 35, I will expect you guys to be able to graph something like this, okay? Because it's a common function. You've been studying it for many years now. So number 35, let's see, we have from here to here, it's decreasing, and then from 3, negative 9 on to the right, it's increasing. So we have decreasing from negative infinity to 3, and then increasing from 3 to infinity. Alright, I take it back. Number 35, they're not asking for the intervals. They are asking for relative maximum and or relative minimum values in the function. So this one, 35, since the parabola is opening up, it has a relative minimum down here. Okay, so we'll just say relative minimum is at 3, negative 9. And that would be the answer for number 35. Apologize for that. Okay, 37, punch into your calculator. Graphing calculator or Desmos, and like I showed you in class with Desmos, it if you hover over the max and min, it gives you the actual coordinates when you place your cursor over the that point, and it looks something like this. Okay, not exact, but something like that. And so the relative minimum would be the point right here, and that the coordinates for that one are negative 703, and the y coordinate negative 16, 864. Okay, the relative maximum, which is the point up here, is 1 3700ths. The y value is 12 1600ths. Okay, so number 39, I'll make this 1 unit right here. And so the graph looks something like this, where it goes through 0, 0, 1. I'm sorry, 1, 0, something like that. Okay, so for this one, it only has one of the, it doesn't have a relative max, it has a relative min, which is down here. So the relative min, and again, using Desmos, is you just hover over that gray point that shows up right here, and then it gives you the coordinates. So it's 0.33, so it looks like it's 1/3, right? Because if when I zoomed in more and more, just it kept adding more 3's to the x coordinate. So this is 1/3 most likely, and then the y coordinate would be negative 0.385. Okay. So 41 is another quadratic which factors. If you factor it, you get the factors x minus 5 times a quantity of x plus 1. So when you factor it, you get this. So remember, the zeros for this quadratic would be 5, so the x-intercepts, and negative 1. Halfway between negative 1 and 5 is 2. So we know that somewhere along the line, x equals 2, we find the vertex. So to find the value, we replace the x with a 2, which gives us negative 9. 2 minus 5 times 2 plus 2. No, wait, 2 plus 1, sorry. So 3 times negative 3 is negative 9. So it would be 1, 2, 3, here somewhere. Connect the points. And again, you can use a graphing calculator to just punch in the quadratic function. But it's always good to review what you learned in the past and apply it, right? So here the relative min is at 2, -9. So 43 is a cubic function. Again, punch it into your calculator. You can do it that way. Or you can factor out the x and then get the zeros for the function that way. But let's just go ahead and graph what we see in the graphing calculator. So it's something like this. Okay, so we know that the relative maximum is going to be here and the relative minimum is going to be right here. So the relative max, you get -1, 2. And I know it's not to scale. Okay, I just kind of sketched the basic shape, but it's not, you know, that point right here that I'm pointing at right now. That this one right here is not -1, 2. It doesn't look like it, right? But I just drew a sketch. And then for relative min, that would be 1, -2. Okay, so that's the answer for that one. Okay, 45 is another quadratic. It does not factor, so I can't, the x-intercepts are not rational numbers, but if you recall from last year where you learned to find the vertex by using this, you can use it to find the x-coordinate, and then to find the y-coordinate you just do f of -b/2a. Okay? Or you can punch it into the calculator and you'll get that it's going to be about here, vertex. Something like that. Okay? And so this one has a relative min at 1, -2. Okay, so number 109 tells you that f of x is an even function, so I just drew the absolute value function as an example of an even function, and then we're going to perform each of the transformations on a through d and see if it still remains an even function after you do the transformation. So a is the opposite of f of x, so basically what this means is that the graph is going to reflect over the x-axis. So it's going to go like that. Okay, so this one is still even. For b, f of -x means that the graph is going to reflect over the y-axis. Okay, so when it reflects over the y-axis, it just imagine holding a mirror on the y-axis and flipping the function so it looks exactly the same as the original. So this one too is even. F of x minus 2 means that the graph is translated 2 units down. So every point moves down 2 units, so it ends up here. So this one, if you look at it, it's still symmetric with respect to the y-axis, so it's still even. Letter D says that it flips over the x-axis, the negative f of x, and the x plus 3 means that it translates to the left 3 units. So it'll be right here at -3, 0, the vertex, and it's going to open down like that. Okay, so this one is no longer even because it's not symmetric with respect to the y, and it's not odd because it's not symmetric with respect to the origin. So this one is neither one.